applying this commutator to the cube, this is the same exact result we had for the standard algorithm. From this point with the standard algorithm, what we did is we did the setup move L prime and then reversed it to move this 1x3 block affected down here. Of course, different pieces will be affected. It will be these pieces affected now. But the 1x3 block affected will now be down here. And then we did the setup move F2 to bring this 1x3 block up here. From there we did the quarter turn so that we had a interior looking J-perm. But now we have to do one slight alternate route from the standard algorithm to form Lucasparity. Looking back at the algorithm itself, and assuming we would take the same route, or at least a similar path to the standard algorithm, we would have the following case. This is how the standard algorithm's interior J-perm is made. However, notice that this L right here will cancel this L prime, hence giving the U2 F2, or the two intersecting 180 degree face turns, which is definitely not how Lucasparity is structured, as pointed out before. In order to prevent this, we need to do a setup move U2 to what we had originally, like so, so that every other move is indeed a face turn. So, applying that to the cube, we have the following result. From here, we need to get all 1x3 blocks in the right slice. And with Lucasparity, we don't need to worry about having all U2s, so we do the same set moves from here as with the standard algorithm. Hence, we do the setup move L prime and then invert it at the end. That moves this down here. And then now we do the setup move F2. And that moves it right there. Adding this in, this is what we have so far. Now, the last move is to do R prime, or move the right slice down. By doing that, we have an interior J-perm. Now it's at the bottom, but that is perfectly fine. Now recall what the setup of the main portion of Lucasparity was, that we had one edge cubey by itself up here, while the other edge cubey involved was down here with the two centers. So what is the last setup move you think we have to do? Maybe you guessed, F2. So if we do F2, it moves this individual edge cubey down here in this slot that is affected by the current algorithm, and then when we undo it, it moves up here. So going ahead and adding in that setup move, we have the exact same setup as the Lucasparity base. Adding that in, oh, and I forgot the R prime here to make it a J-perm. So that's the result we have. If we just add in R2 now, as in before, to fill it in from what we had before, is nothing new. We have this. Now adding in the outermost setup moves, R, U2, R prime, to take care of the centers, we have a pure algorithm. Hence, this right here is Lucasparity's outline, without doing any move cancellations or any speed optimizations. So speaking of move cancellations, let's go ahead and cancel. F2 and F2 go. The R2 and R prime become R. The U2 go. The L and the L prime go. And the R2 and the R become R prime. Writing on one line, and adding in cube rotation for faster execution. See, F2, if we do X, it'll become U2. But we have to undo that setup move X before we get to the next face turn to have this. And then from that, if we want to convert to Y turns, we have a much faster form, which is even faster if we take this LWX and just convert it to RW. Or just removing the parentheses, Lucasparity. Making sure that we didn't mess up, let's go ahead and apply it to the cube, see what we get. And there it is. Therefore, the fastest algorithm according to many cubers, Lucasparity, is not that much different than the standard algorithm. Only one extra setup move is needed to prevent two intersecting 180-degree turns of faces. Everything else, all the other setup moves are the same for the main base is concerned. And then we do one extra setup move, F2, at the end to finally set up for the outermost setup moves, which eliminate double turns of R. So that all you have are just single turns of R instead of R2. Well, that's it for today.